Hey 7th graders, today's assignment is 3.2 natural selection. Your learning target, I can identify if a trait formed by a mutation will be adaptive or non-adaptive based on the environment in which the organism lives. Okay, so basically we started learning a little bit about how mutations can arise in a population and cause either adaptive or non-adaptive traits, and we looked at how that happens and what that might look like in a histogram, looking at maybe a 50 generation difference. Today we're going to look a little bit more at whether or not that trait that arises is actually going to be adaptive or not. All right, so first thing you guys are going to add to your notebook are these 3 key concepts. So you got key concept 9A, 9B, and 10 into your key concepts page of your natural selection section. 9A states, mutations are changes to genes that can lead to changes to protein molecules, which can result in changes to traits. So remember that really more often than not, we can have a mutation in our genes that we don't even know what happens. It doesn't cause an effect at all. If it does happen to cause a new trait, that trait can either be adaptive, where it helps the organism survive and reproduce better, or it could be a non-adaptive, where it really doesn't matter if that organism has that trait. It doesn't help them in any way. And, you know, maybe it hurts them more than anything. Okay? So 9B, mutations to genes can sometimes introduce new traits to a population. Again, sometimes. This really doesn't happen as often as you guys would like to think it does. More often than not, like I said, mutations don't cause anything significant to happen at all. And then finally 10, a new trait will only become more common in a population if it's adaptive. So if it's non-adaptive, there's really no point passing it down. There's no benefit passing it down. It doesn't make the organism more likely to survive and reproduce, so we don't necessarily see it being passed down more frequently. Whereas an adaptive trait, again, it makes an organism easier to survive in its environment and reproduce in its environment. Therefore, we would see it be passed down more often. All right. Moving on to your warm-up. So you guys have a little histogram here to look at. You guys can notice that we're talking about the first generations right here. So these are different generation 70 versus generation 25. So this one's the earlier histogram that you see here. Okay. And then you guys notice that we're looking at fur distribution. So how much fur these organisms have. Okay, so your questions to answer on this: what similarities do you notice in what happened to the population with mutations and to the population without mutations? So first you guys are going to kind of need to decide which one had mutations and which one didn't have mutations. Okay, so what similarities do you see? And then what differences do you notice in what happened to the population with mutations to the population without mutations? So again, it might help you guys to circle the population, either this one or this one, which one had mutations. Okay, all right, moving on. Activity 3, simulation. Observing mutations in the natural selection simulation. So in the sim activity that follows, you will investigate a low fur population, so they have really thin fur, of australopes with the trait distribution shown in the histogram below. I'll show you guys that here in a second. In this sim, you'll be able to turn on mutation for fur traits. You will make the environment for this population cold. Again, we did this a couple lessons ago. You guys got to see what happens with, all right, we had population A. It went cold. You guys kind of saw a shift in the distribution of fur traits. And then you guys had population B, which had a really low variation of thin fur. And then you guys saw that population go extinct, okay, when it got cold. Okay, so you guys will make the environment for the population cold. And before you do this, you'll study the histogram below and answer the questions that follow. Okay, so here's the histogram you guys are looking at here. Think about which new traits would be adaptive and non-adaptive in a cold environment. Label any traits that would be adaptive with an A. So you guys see these little boxes with the A's. You guys will click and drag them. And then label the ones that you guys think would be adaptive in a cold environment. Remember, 1 is really low, like thin fur. And number 10 is high, thick fur. Okay? And then label the ones that you think are non-adaptive with an NA. So drag an NA to the spot of the ones that you guys think are non-adaptive. Obviously, you guys will notice there's a lot of extras A's and non-A's than you guys will need. So you guys will have some left over, and that's okay. Then answer this question here. Are all traits that are introduced by mutations adaptive? Again, your keyword there is all. Are all traits that are introduced by mutations adaptive? Do you think non-adaptive traits can be introduced into a population through mutation? Why or why not? So kind of 3 questions to answer there. Make sure you guys address all 3. So first of all, do you think all traits are adaptive when they're introduced by mutations? Do you think non-adaptive traits can be introduced into a mutation through adaptations? And then explain why or why not. All right, moving on to your actual sim. So you guys will need to right-click your link over here. Open up your simulation. You guys are going to be testing predictions in the natural selection sim. Your goal is to perform tests in the sim to see if mutations can introduce both adaptive and non-adaptive traits into the population. So your do is to open the sim and open mutation and traits. So here's our sim. We're going to go to these 3 horizontal bars and we're going to find mutations and traits and load that up. Change the temperature of the environment to cold, level 1, by moving the temperature slider. Turn the Australope fur trait mutations on by pressing the little icon and toggle. All right, so we're going to go here. Temperature is cold. Australopes, we're going to make sure our mutations are on. So we click the little icon and then turned our mutations on. And then press run and observe the population for at least 50 generations. So make sure you guys speed it up when you do that. So click through, hit run, speed it up. Let it run for 50 generations. Press Analyze and use the Generation slider to carefully observe new traits in the population. Answer the questions below. So some tips for you. Press the histogram icon in the lower left-hand corner of the run to observe and the introduction of traits. So you guys can watch this little thing here as it changes. So you guys can kind of see what it looked like before, and then as it's changing, what's happening. So there was another big change. And then look for the red indicator above the heads of Australopes that are born with mutant traits. So if you guys zoom in, you guys can see this little red dot. That shows us when there's been a mutated trait here. Okay, and then we can, of course, hit Analyze after our 50 generations. Of course, I only went 6. So you guys can see, here's what mine looked like originally. So it looks like all of my population had the slightly thicker fur, okay? So a 2. And then at the end of even 6 generations, we had some 1s, some 3s, and some 4s arise. Think about which ones would be adaptive for a cold environment and which ones would be non-adaptive. Okay, so can you guys have non-adaptive traits arise? That's kind of the question you guys are looking for here. All right, moving on. First and foremost, you guys need to take a screenshot of your Australope fur histogram. So that would be this one here, but obviously this should have 50 generations on it. So you guys will need to take a screenshot of that. If by this point you guys don't know how to do that, make sure you guys ask me and I can help you, but I'm not going to explain it in this video. I've done it just about every other video. Okay, so that's your generation 50. Use your highlighter in the draw tool to show any adaptive traits. So we're only looking at adaptive traits that were introduced through mutations. So these aren't going to be adaptive traits that already exist. They're going to be new traits that form from mutations. And I only want you guys to highlight the adaptive ones. Okay, so you guys would go in, you'd use your highlighter and just either highlight or throw a strip down the bar that shows you guys adaptive traits that came about from a mutation. Okay, answer this question. How do you know the traits you indicated in the above histogram were adaptive? Okay, how do you know they were adaptive? What did you see in that histogram that let you know that they were adaptive and they helped the organism survive and become more reproductively successful? And then you're going to take a screenshot of the Australope fur trait histogram for generation 5 and upload it and paste it here. So you guys will need to drag that slider until you guys have a 5. Just kind of like that. Use the highlighter in the draw tool to show any adaptive traits. So same thing, make sure you guys use that highlighter in the draw tool and highlight the bars that show any adaptive traits that came from a mutation. Okay, so that would be generation 5. So you guys have a 50 and a 5 that you're looking at right there. Then answer these questions. How do you know the traits you indicated in the above histogram were non-adaptive? Okay, so let's actually have that be, sorry, I'm going to reverse you guys real quick. I think this one's supposed to be any non-adaptive traits. So on this one, I want you guys to highlight any non-adaptive traits. Okay, and just after generation 5, I think is supposed to be the correct thing there. I think I did some copy and pasting errors. All right, so then how do you know that the highlighted columns you guys did in that were non-adaptive? Revise your earlier answer to these questions. Are all traits that are introduced by mutations adaptive? Do you think non-adaptive traits can be introduced into a population through mutations? Why or why not? Okay, at this point, you guys maybe had the right answer the first time through, but now you have a little bit more evidence to support your answer. So when I say revise it, I want you to actually change something and add some of that new evidence that you guys saw through your histograms in the information you just got out of the sim that you ran. All right, moving on to almost our last section here. Little reflection for you guys. You have old Mr. Sherman again. Let's see what that crazy guy's up to. Woo! It's really cold here. These rabbits must be glad they have long fur. This environment used to be warmer. It has gotten colder over many generations, and long ago, when it was warmer, there were no long-haired rabbits here. How is that possible? I thought adaptive traits had to be present in order for a population to adapt to its environment. Yes, but we know that every so often mutations can introduce a new trait into a population. So you guys can see that little red indicator showing he had a mutation. Oh, I get it. The rabbits must have been cold, so they had an adapted mutation for long hair so they could survive. Well, no, Sherman. Mutation doesn't really work like that. Here's how it really works. And so you guys, of course, are going to address how it really works. So complete the explanation to Sherman. Well, no, Sherman, mutation does not really work like that. Here's how it really works. So you guys would tell me, how does mutation really work, okay? An animal doesn't just say, I'm going to have a mutation, pop. Now I have a mutation that's going to make me more adaptive. All right, and then answer this question using your draw tool. If there had been a mutation that led to no fur, what would have happened? So circle your guys' correct answer there. There's only one. Finally, last little section, you have a reading activity, how to make a venomous cabbage. So you guys can go ahead, right-click that, open it up, and amplify. As you guys read through that, you guys will be looking for answers to these questions. What is artificial selection? So we are learning about natural selection. So what is artificial selection? And how does it work? Why is artificial selection useful for farmers? And how is genetic engineering different from artificial selection? So there's a big difference there, okay? We got natural selection now. We look at what like farmers and ranchers do with artificial selection, or even like dog breeders, for instance, is a good example. But what is genetic engineering and how is it different? Okay, so your article looks like this. How to make a venomous cabbage. So we talk about turning this cabbage into something that would be venomous for insects, but not for human beings. So if an insect were to eat it, they would die and not obviously hurt the plant itself. And it wouldn't hurt the people that eat it. Okay, but how could we genetically engineer that to make a venomous cabbage to do that? Okay, it would prevent farmers from having to use insecticides or pesticides. Okay, so read that article, learn a little about where we're getting the venom from, or where we're getting the gene for the venom from. You guys can definitely listen to it if you guys click the speakers right here and then click play. And then finally, you're all done. Go ahead and complete your wrap-up. Do you have any questions? Circle yes or no. If you have any questions, type them here. And then 4, 3, 2, 1, how do you think you did on your assignment? You are all done. Go ahead and hand it in, and I hope you're having a great day. Bye.